Hello again with another video related to vectors, quantities, or vector components. In this example here, I have a Superman flying downward, and from the position of the angle, I can say it's off east to south, 30 degrees, with a speed of 100 meter per second. Now the question asking, what is the x and y components of Superman velocity? Uh, we can follow the same procedure. I will say this one here is the Vx component, and here will be the Vy component. So again, if I close the triangle, that will be Vy, and we look at our angle. So I can say that the Vx, it will be the adjacent, which means gonna be the V cosine 30 degrees. That's 100 multiplied by cosine 30. We just do some calculation, and it will give us 86 meter per second. Okay, now for the y component, it will be the opposite of the angle, which means it will be V sine 30 degrees. Again, it's 100 multiplied by sine 30. It will be 50 meter per second. However, we mentioned in our previous video that we have to pay little more attention about the position of my vector in which quadrant or the direction of these components. So when I look to the Vx or the x component, the direction is to the right or to the east, so it will be positive, which is great. However, when I look to the y component of the velocity, it's going downward or to the south, so it should be negative to represent the direction of this component. Now, that's one. Also, we mentioned that in which quadrant it should alert me which component should be positive, which one be negative. This is a quadrant 4. Quadrant 4, the cosine will be positive, which what we have here. And in quadrant 4, the sine component should be negative. That's why we put the negative. But the reality is the direction is a negative. Now, if I want to do the same question in a different way, I could try this technique, which is I'll start from 0 and go around, and this is gonna be my angle, and this angle will be 330 degrees. Okay, now to calculate it this way, the angle is being located between the x-axis and the vector, which means the Vx will be again it will be the adjacent, which means the V cosine 330. So here is 100 cosine 330, just by doing some math, 100 cosine 330, and it will give us, excellent, it's going to give me exactly 86 meter per second, and it's a positive because the calculator recognized I'm on quadrant 4. Now if I go with the y component, which it will be the opposite, so V sine 330, and if I do the math again, 100, that will give me 50 meter per second negative, which represent the direction is going downward. Right? So either way you take, it's fine. It will get you to the right answer as long as you pay attention to the details and which way you take. Okay. Now let's try another different example. I have here an airplane, it's taking off with a certain angle. Now the question is already giving me the x component and the y component of the velocities. So technically This is the Vy, and this one here is the Vx, asking me how fast is the plane traveling. So I was trying to find the resultant. Now, to do this, we should follow the rules to find the result, which is going to be Vx component square plus the Vy component square and all under square root. So it's going to be 120 squared plus 80 squared and all under square root. Let's do some math. And that will give us 144.2 meter per second. That's the resultant. That's the magnitude of the airplane velocity. Now, asking me for the angle theta, that will help me to identify the direction of this airplane, which we can say it is off east to north or with the horizontal. So to do that, we have different ways we can do it. Simply, I have the adjacent and the opposite of the angle, which means I can use the tan, because tan theta equal the Vy over Vx, and from here I can calculate the tan inverse of the Vy over Vx. That's, sorry about this one, let's fix it. Okay, that's 80 over 120 to calculate the tan inverse. And that will give us 33 degrees the angle. So that's one technique. Someone might use the concept that we do know how much is the magnitude of each component, the x component and the y component, and we know how much is the resultant or the total velocity of the airplane. So we can use the concept of Vx, the x component, equal V cosine theta. So from here, I can say theta will be the cosine inverse of Vx over V. So Vx, we know it's 120, and the V is already being calculated, it's 144.2. To do the cosine inverse, you will get 33 degrees again. Someone else might use, okay, I will use the y component. So the Vy will be the V sine theta. Once again, theta will be the sine inverse of the y component of the velocity over the velocity. And if you do the calculation, you will get again the same angle, which is the 33 degrees off east to north. Okay, this is the way how we handle components or the resultant, or even finding the direction of a certain vector between the x and y. I hope you find this video useful, and I will see you with another one. Thank you.